Hey, welcome to week 8, atoms, fundamental particles, and atomic forces. Last week, you learned how the atomic theory developed through centuries of observation and experimentation. Now it's time to learn about the atom itself. This week, you'll learn about the particles inside the atom, and you'll learn about the forces that act on those particles. But first, you'll have to find out how small an atom really is. So our learning target is that we will be able to conceptualize the relative size of an atom. The photograph here shows the pattern that's formed when a beam of electrons is directed at a sample of aluminum. By analyzing this pattern, scientists can determine the size of an atom. Analysis of similar patterns for many elements has shown that aluminum atoms, which are average sized atoms, have a diameter of about 0.0000003 centimeters. That's 300 millionths of a centimeter. That's so small that it would take a stack of 50,000 aluminum atoms to equal the thickness of a sheet of aluminum foil from your kitchen. Now, another example to think about is just an ordinary penny. Now, believe it or not, a penny contains 2 times 10 to the 22nd atoms, which can be written as 2000000000000000000000000 atoms of copper. And of course, there's some zinc in there too. That's 20,000 billion atoms, or over 3,000 trillion times more atoms than there are people on the earth. So if there are that many atoms in a penny, each atom must be very, very small. If you could enlarge a penny until it was as wide as the continental United States, each of its atoms would only be about 3 centimeters in diameter, about the size of a table tennis ball or a ping pong ball. So, question is, are you able to conceptualize the relative size of an atom? Are you able to imagine how small, how incredibly small an atom is? If not, feel free to go back and view this video clip one more time, or you can move on to the videos that are listed below.